can access them as well. So let's see, when I run this program, Python of bank.py, I would hope, based on my own intuition thus far, that I'm going to see that my current balance is 0. That is to say, even though the balance variable is defined on line 1, hopefully I can still print it on line 5 inside of main, even though balance was not defined in my main function. Here we go, hitting enter, and voila, balance 0. So it does seem to work. Even if you declare a variable in Python outside of your functions, it appears that you can access it. You can read the value of that variable even inside of a function like main. Well, let's get a little more adventurous now, because this program really isn't solving anyone's problems. Let's go ahead and implement more of a bank, like the ability to deposit money into the bank and to withdraw money from the bank, thereby giving me some more functions that might very well need to access that same variable. Let me clear my terminal window here, and let me go ahead and pretend for the moment that I have the ability to deposit, say, $100 or 100 coins, whatever the unit of currency is here. And then maybe I want to withdraw straight away 50 of those same dollars or coins. And now let me go ahead and just print out at the bottom of main what my new balance should be, so that in an ideal world, once I've deposited 100, then withdrawn 50 after starting at 0, I'd like to think that my new balance on line 8 should indeed be 50. All right, but I haven't implemented these functions yet, so let's do that as we've done in the past. Down here, I'm going to go ahead and define another function, deposit. I'm going to say that it takes an argument called n for a number of coins or dollars or the like. And I'm just going to do this. I'm going to go ahead and say balance plus equals n, thereby changing the value of n. I could do it more verbosely, balance equals balance plus n, but I'm going to use the shorter hand notation here instead. And now let's implement withdraw. So define a function called withdraw. It too is going to take a variable, an argument n for number of dollars or coins. And now I'm going to go ahead and subtract from balance using minus equals n as well. And I'm still going to call main if the name of this file is main. So what have I done? I've just added not just one, but 3 functions total, all of which apparently need to access balance by printing it, incrementing it, or decrementing it, as we've seen here. All right, let me go ahead and focus on these 3 functions here. Let me go back to my terminal window and run Python of bank.py and hit enter. And wow, seems like we've introduced some number of problems here. And what are these problems? Well, unbound local error is perhaps the first time we've seen this one here. Local variable balance referenced before assignment. And that's a bit misleading, definitely confusing, right? Because I absolutely assigned balance a value on the top of my code. And indeed, if I scroll back up, nothing has changed or been lost up there. It's definitely been assigned a value. And now on line 12, it would seem that when deposit is called, I'm just trying to access that variable again. So intuitively, what might explain this error message? Unbound local error. What is Python telling us there that Python can or can't do when it comes to these so-called global variables that are at the top of my file?
So if you want to change this variable, you should write inside def function main, and global variable unchangeable.
Yeah, so if you want to change the value, it might need to be local to the function. If you are trying to change a global variable, though, in a function, it clearly does not work. So it's OK to read a global variable, read meaning access it and print it and so forth. But apparently, you can't write to a global variable in the same way from within one of these functions. All right, well, maybe the fix is to do this. Let me clear my terminal window in that error. And maybe I could just do this. Let's get rid of the global variable. And let's go ahead and put it, for instance, inside of main. Might this now work? Well, let me try this now. Python of bank.py enter. That alone did not solve it. I still have an unbound local error. This time, though, it's for a different reason. It turns out now that balance on line 2 is by definition a local variable. A local variable is one that exists in the context of a function, at least in this case. A global variable is the opposite, one that does not, for instance, at the top of my file. So here is another distinction in Python. If you declare a variable in a function like main, just as I've done on line 2 with balance, it is indeed local to that function. Deposit and withdraw do not have access to that same variable. Why? Because it's local to main. And so you would think now we're kind of stuck in this vicious cycle. Well, maybe the solution then is to move balance globally, so all three functions can access it. But clearly, where we began, as Olena noted, we can't therefore change it. So it turns out the solution to this problem in Python is, ironically, exactly this keyword here. It's a little different, as you might have seen if you programmed before in other languages, but there's indeed a keyword in Python called global that allows you to tell a function that, hey, this is not a variable that's local to you. I mean it to be a global variable that I want you to edit. So if I go back to VS Code here, clearing my terminal window to get rid of that error, let me go ahead and undo the change I just made and put balance back at the top of my file. But this time what I'm going to do is I'm going to inform my two functions that need to change the value of balance, that it is indeed global by typing global balance. Again, here as well as here, global balance. I still leave the same lines of code now on lines 13 and 18 that increment and decrement balance, but this now use of keyword global is a little bit of a clue to Python that, oh, OK, it's not a local variable. This is not a bug that you've introduced. You mean for me to edit this variable up above. So now let me go ahead in my terminal window and run Python of bank.py. I'm hoping to see that my balance is 0 plus 100 minus 50 is 50. And indeed, it now is. It starts off at 0 per my first print statement on line 5, but it ends up at 50 total at below that on line 8. Let me pause here to see if now there's any questions on these global or local variables.
What happens when you declare a variable globally and as in the same variable globally and in a function?
A good question. You're always thinking about the so-called corner cases. So if you declare a variable both globally, like at the top of your file, and then an identically named variable inside of a function, same name, the latter will shadow, so to speak, the former. That is, you'll be able to use the latter, that is the local variable, but it will have no effect on the global variable. Temporarily, Python will only know that the local variable exists. So in general, the rule of thumb is just don't do that. Not only might it create bugs in your code because you don't quite change what you intend to change, it's also perhaps non-obvious to other readers as well. Other questions on globals or locals?
Okay, what if we decide to add balance as an argument inside the main function?
Yeah, another good instinct, but in this case, that also is not going to solve the problem, because if you pass in a variable like balance to each of the functions and then change it within that function, it's only going to be changing, in effect, a local copy thereof. It's not going to be changing what's outside of those functions. So I think we actually need a better way altogether, and in fact, allow me to transition to perhaps a modification of this same program. Recall that we looked most recently at this notion of object-oriented programming, whereby you can model real-world entities, for instance, a bank, and you can model and encapsulate information about that real-world entity, for instance, like someone's account balance. So let me propose that we actually do this. Let me start from scratch with bank.py, get rid of the global variable altogether, and actually use some object-oriented code. Let me define a class called account to represent someone's bank account, and then let me go ahead and initialize with my init method, which again takes by convention at least one argument called self. Let me go ahead and initialize every person's bank account to some value like 0. Now, how can I do that? Well, I'm going to go ahead and do self.balance equals 0, thereby giving me an instance variable called balance initialized for this account to 0. But I'm going to proactively remember how we also introduced this notion of properties, which might otherwise collide with the names of my instance variables. So just by convention, I'm going to do this. I'm going to rename this instance variable proactively to underscore balance to effectively indicate that it's private, even though that's not enforced by Python. It's just a visual clue to myself that this is something that really I should not, or other code should not touch, just functions in this class. Now let me go ahead and do this. Let me go ahead and define an actual function called balance that really is going to be a property whose purpose in life is just to return self.balance. And I'm going to go explicitly and say this is indeed a property of this class. Now let me go ahead and re-implement those other two functions, deposit and withdraw, but in the confines of this class. So I'm going to say define deposit. It's going to take in an argument self as always, but an additional one, n, a number of dollars or coins to deposit. And how do I now manipulate this? Well, I'm going to do self._balance plus equals n. And now down here, I'm going to do def withdraw self n, just like for deposit, but here I'm going to do self.balance minus equals n. And now, if I go down below this class, I'm going to go ahead and define myself a main function, just so I can try this now out. I'm going to go ahead and create an account object by calling the account constructor. That is the name of the class with 2 parentheses if I'm not passing in any arguments to init. I'm going to go ahead now and print out, as before, the balance of my account. But to do that, I'm going to access the property of that account like this. And I'm going to go ahead now and say deposit another $100 or coins with deposit 100. And I'm going to go ahead like before and also now immediately withdraw, for whatever reason, 50 of the same. And now I'm going to print one last time balance followed by account.balance, again accessing that property. And for this whole thing to work, of course, I need one of these if name equals underscore main. Then go ahead and call main. Now, before I run this, you'll see that it rather escalated quickly. I had a very simple goal at hand to implement. Now, before I run this, you'll see that it rather escalated quickly. I had a very simple goal at hand to implement the notion of a bank, and I was able to implement that perfectly fine ultimately by declaring balance to be global, but then to tell each of my functions that it is indeed global. But that's not really the best form of encapsulation we have at our disposal now, right? Per our focus on object-oriented programming, if we're trying to implement some real-world entity like an account at a bank, that's what classes allow us to do. And it allows us to solve that same problem perhaps a little more cleanly, certainly if we're going to accumulate more and more functions or methods over time. So if I didn't make any mistakes here, if I run Python of bank.py and hit enter now, you'll see that it just works just fine. Because in the world of classes in Python, these so-called instance variables are by definition accessible to all of the methods in that class because we're accessing them all by way of that special parameter self. So which way to do it? For a reasonably small script wherein you are simply trying to implement a script that has some global information, like an account balance that you then need to manipulate elsewhere, the global keyword is a solution to that problem. But generally speaking, in many languages, Python to some extent among them, using global variables tends to be frowned upon only because things can get messy quickly. And it can become less obvious quickly exactly where your information is stored, if some of it's up here, some of it's in your function. So generally, the rule of thumb is to use global variables sparingly. Though technically speaking in Python, these global variables are technically local to our module if we were indeed implementing a library and not just a program. So in short, try to use global variables sparingly, but when you do, there is a solution to these same problems. Questions now on globals or our re-implementation of the same idea, but using full-fledged object-oriented programming?
I just would like to ask what this property does.
What this property does. So if I go back to VS Code here, you'll see that this was a technique we looked at in our lecture on object-oriented programming, whereby a property is an instance variable that's somehow protected. It allows me to control how it can be read and written. So in this case, I only have what's called generally a setter. In this case, I only have what's generally called a getter. And there's no mention of the word getter here. This is just what @property means. That function balance will allow me, recall, to use syntax like this, where I can pretend as though balance is indeed, with no underscore, an instance variable. But I can now prevent code like mine in main from trying to change balance. Because I do not have a setter, I would not be able to do something like account balance equals 1,000 to just give myself $1,000 or coins because I have not defined a setter. So again, per our focus on object-oriented programming, these properties just allow me some finer-grained control. Some languages allow you to define variables that are, so to speak, constant. That is, once you have set a value to them, you cannot change the value of that variable. And that tends to be a good thing because it allows you to program defensively. Just in case you accidentally or someone else accidentally tries to modify the value of that variable, if you have declared it in some language as a constant, it cannot be changed, or usually cannot be changed without great effort. Unfortunately, in Python, we're again on the sort of honor system here, where we have conventions to indicate that something should be treated as though it's constant, but that's not actually enforced by the language. So for instance, let me go back here to VS Code, and let me create a new file, for instance, called meows.py. And let's see if we can't implement the notion of a cat meowing on the screen. So I'll do code of meows.py. And in meows.py, let me go ahead, for instance, and implement a very simple program that just has a cat meowing 3 times. So how about this? For I in the range of 3, go ahead and print out quote unquote meow. All right, well, we've seen in the past how we can clean this up a little bit. For instance, if I'm not actually using I might as well Pythonically just change the name of that variable to underscore, even though that has no functional effect here. But here we have this 3 sort of randomly hard-coded, that is typed explicitly into my code. And it's totally not a big deal when your code is only 2 lines. But imagine that this is a much bigger program with dozens or even hundreds of lines. And imagine that one of those lines just has a 3 in there somewhere. Like, you're never going to find that 3 very easily. And it's going to be very easily overlooked by you or colleagues or others that you've hard-coded some magic value like a 3 right there in your code. So it tends to be best practice, not just in Python, but other languages as well. Anytime you have what is essentially a constant, like a number 3 that shouldn't ever change, is to at least let it bubble up, surface it to the top of your code so that it's just obvious what your code's constant values are. And so by that I mean this. At the top of this file, it would probably be a little clearer to colleagues and frankly me tomorrow after I've forgotten what I did today to define a variable like meows and set it equal to 3. And then instead of hard coding 3 here, or even lower in a much bigger program, let me just go ahead and pass in that variable's value to my loop so that now it's just kind of obvious to me that meows is apparently the number of times to meow. And if I ever want to change it, the only code I have to change is at the very top of my file. I don't need to go fishing around or figure out what's going to break, what do I need to change. I just know that I can change these constants up at the top. The problem, though, with Python is that Python doesn't actually make variables constant. It's indeed a convention in Python and some other languages to at least capitalize your variables when you want to indicate to the world that you should not touch this. It is constant. But there is literally nothing in my code preventing me from saying, you know what, today I feel like 4 meows instead. Like, that would work. In other languages, though, there's typically a keyword or some other mechanism syntactically that would allow you to prevent line 3 currently from executing so that when you tried to run your code, you would actually get an error message explicitly saying you cannot do that. So Python, again, is a bit more on the honor system when it comes to these conventions instead. Now, it turns out there's other types of constants, quote unquote, that Python typically manifests. And in fact, let me go ahead and change this around a little bit. Let me delete this version of meows. And let me introduce, again, a class from our discussion of object-oriented programming, like a class representing a cat, another real-world entity. Recall that within classes, you can have not just instance variables, but class variables. That is, variables inside of the class that aren't inside of self per se, but they're accessible to all of the methods inside of that class. Here, too, there's a convention, but not enforced by Python, of having class constants, whereby inside of the class, you might want to have a variable that should not be changed, but you just want to indicate that visually by capitalizing its name. So for instance, if the default number of meows to all of the methods inside of that class. Here too, there's a convention, but not enforced by Python, of having class constants, whereby inside of the class, you might want to have a variable that should not be changed, but you just want to indicate that visually by capitalizing its name. So for instance, if the default number of meows for a cat is meant to be 3, I can literally, inside of my class, but outside of any of my defined methods, just create a class variable, all capitalized, with that same value. And then if I want to create a method like meow, for instance, which as an instance method might take in self, as we know, and then I might have my loop here for underscore in the range of, and now I need to access this. The convention would be to say cat.meows to make clear that I want the meows variable that's associated with the class called cat. Then I'm going to go ahead and print out one of these meows. And now at the bottom of my code, outside of the class, let me go ahead and do something like this. Let me instantiate a cat using the cat constructor. Notice this is important. Per our discussion of OOP, the class is capitalized by convention, but the variable over here is lowercase. And I could call it just C or anything else, but I kind of like the symmetry of calling it little cat here and big cat, so to speak, over here. And now if I want this particular cat to meow that default number of 3 times, I can just do cat.meow. Meow like this, and that method meow is going to, per line 5, access that P. The class is capital constructor of the class. I'm going to go ahead and print out one of these meows. And now at the bottom of my code, outside of the class, let me go ahead and do something like this. Let me instantiate a cat using the cat constructor. Notice this is important. Per our discussion of OOP, the class is capitalized by convention, but the variable over here is lowercase. And I could call it just C or anything else, but I kind of like the symmetry of calling it little cat here and big cat, so to speak, over here. And now if I want this particular cat to meow that default number of 3 times, I can just do cat.meow like this. And that method, meow, is going to, per line 5, access that class constant. But again, it's constant only in the sense that you should not touch that, not that it's actually going to be enforced by the language. All right, let me go ahead then and run this with Python of meows.py. And there it is, 3 of our meows, meow, meow. It turns out that Python is a dynamically typed language. That is to say, it's not strongly typed, whereby when you want an int, you have to tell the program that you are using an int. You don't have to tell the program that you are using a stir or a float or a set or anything else. Generally speaking, to date, you and I, when we're creating variables, we just give a variable a name. We frequently assign it using in the equal sign some other value. And honestly, Python just kind of dynamically figures out what type of variable it is. If it's quote unquote hello world, the variable is going to be a str. If it's 50, the integer, the variable is going to be an int. Now, in other languages, including C and C++ and Java and others, it's sometimes necessary for the programmer to specify what types of variables you want something to be. The upside of that is that it helps you detect bugs more readily, because if you did intend for a variable to store a string or an integer, but you accidentally store an integer or a string, the opposite, or something else altogether, your language can detect that kind of mistake for you. When you go, for instance, to run the program, it can say, no, you've made a mistake, and you can fix that before your actual users detect as much. In Python 2 here, it's again more of a friendly environment where you can provide hints to Python itself as to what type a variable should be, but the language itself does not strongly enforce these. Rather, you can use a tool that will tell you whether or not you're using a variable correctly, but it's typically a tool you would run as the programmer before you actually release your code to the world. Or if you have some kind of automated process, you can run this kind of tool just like you could reformat or lint your code with some other program before you actually release it to the world. So how might we go about using these so-called type hints? Well, they're documented in the usual place in Python's own documentation. And it turns out there's a program that's pretty popular for checking whether or not your code is adhering to your own type hints. And that program here is called MyPy, and it's just one of several, but this one's particularly popular and can be easily installed in the usual way with pip install MyPy. And its own documentation is at this URL here, but we'll use it quite simply to check whether or not our variables are indeed using the right types. So how can we go about doing this? All right, let me go back here to VS Code, clear my terminal window, and in fact erase meows.py as it currently was, and let's implement a different version of meows that quite simply has a function called meow that does the actual meowing on the screen, and then I'm just going to go ahead and call that function down toward the bottom. I'm not going to bother with a main function just for simplicity so that we can focus, as always, only on what's new. So here we are defining a function called meow. It's going to take a number of times to meow, for instance, n for number, and inside of this function, I'm going to do my usual for underscore in the range of n, go ahead and print quote unquote meow. So based on our earlier code, I think this is correct. I've not bothered defining the variable as I. I'm instead using the underscore because I'm not using it anywhere. But I think I now have a working function whose purpose in life is to meow 0 or 1 or 2 or 3 or more times. Well, let's use this function. Again, not bothering with main. I'm just going to keep my function at the very top because there's only one. And I'm going to write my code here on line 6. So I'm going to ask the user for a number. And I'm going to go ahead and prompt them in the usual way for that number of times to meow. And now I'm going to go ahead and call meow on that number. Now, some of you might see what I've already done wrong, but perhaps I myself don't. So let me go into my terminal window and run python of meows.py, the goal being to prompt me. This seems to be working. I'm going to type in 3, and I would expect now the meow function to print out meow 3 times. Enter. But no. There's some kind of type error here. Str object cannot be interpreted as an integer. Why might that be? Why might that be?
Because the input function returns a string instead of an integer.
Exactly. The input function returns a string or a str, not an int. So in the past, of course, our solution to this problem has just been to convert the string to an int by using the int function. But now let me start programming more defensively so that, honestly, I don't even find myself in this situation at all. Let me go ahead and do this. Let me add what's called a type hint to my function that explicitly specifies for meow what type of variable should be passed in. I'm going to go ahead now and change the very first line of my code in my function to specify that n colon should be an int. And this is a type hint. The fact that I've added a colon, a space, and the word int is not creating another int or anything like that. It's just a hint, an annotation, so to speak, to Python that this variable on the left called n should be an int. Now, unfortunately, Python itself doesn't care because, again, these type hints are not enforced by the language, and that's by design. The language itself in the community prefers that Python be dynamically typed, not so strongly typed as to require these things to be true. But if I run meows.py, type in 3 again, the same error is there. But let me go about trying this MyPy program, an example of a program that understands type hints, and if I run it proactively myself, can find bugs like this in my code before I, or worse, a user, actually runs and encounters something cryptic like this type error here. Let me clear my terminal window, and this time run mypy space meows.py. So I'm going to run mypy on my program, but I'm not running Python itself. When I hit enter, we'll see this. All right, we see now that MyPy found apparently an error on line 7. Error, argument 1 to meow has incompatible type stir expected int. So it's still an error message, but MyPy is not a program that my users would use. This is a program that you and I as programmers would use. And because we have run this code now, before we, for instance, released this program to the world, I can now see, even before the code is called or run, oh, I seem to be using my argument to meow wrong. I had better fix this somehow. Well, I can actually go about adding type hints even to my own variables here so as to catch this another way too. If I know on line 6 that I'm creating already a variable called number, and I know already that I'm assigning it equal to the return value of input, I could give MyPy and tools like it another hint and say, you know what, this variable called number should also be an int. That is to say, if I now start getting into the habit of annotating all of my variables and arguments to functions, maybe MyPy can actually help me find things quite quickly as well before I get to the point of running Python itself. Let's go ahead and try this again. MyPy of meows.py and hit enter. And this time, notice that MyPy actually found the mistake a little more quickly. Notice this time it found on line 6 that error, incompatible types in assignment, expression has type stir, variable has type int. So before I even got to the point of calling meow, line 6 via this type hint, when used and analyzed by MyPy, has helped me find, oh, wait a minute, I shouldn't be assigning the return value of input to my variable called number in the first place. Why? MyPy has just pointed out to me that 1 returns a stir. I'm expecting an int. Let me fix this now instead. All right, so let me clear my terminal window, and now let me do what most of you were probably thinking I should have done in the first place after all of these weeks, but now let me go ahead and convert the return value of input to an integer. For today's purposes, I'm not going to try to catch any exceptions or the like. We're just going to assume that the user types this in properly. And now let me go ahead and run mypy of meows.py, having not only added 2 type hints to my argument, to my function, to my variable down here on line 6, and I've also now fixed the problem itself. Let me go ahead and run mypy, and success. No issues found in one source file. Now, it's more reasonable for me to go and run something like Python of meows and just trust that when I type in 3, at least I'm not going to get a type error. That is, I didn't mess up as a programmer with respect to the types of my variables. Why? Because when I wrote the code in the first place, I provided these annotations, these hints that inform tools like MyPy that my intention had better line up with what the actual code does. Let me pause here and see if there's now any questions on type hints or MyPy.
Is it common, or how common is it for those to be used, or is it just that it's more used in more complex code where it's more difficult to ensure that you're actually using the correct type in the way that you're using the variables?
It's a good question, and it's rather a matter of opinion. Python was designed to be a little more versatile and flexible when it comes to some of these details, partly for writability, to make it easier and faster to write code, partly for performance, so that the program like Python doesn't have to bother checking these kinds of details. We can just get right into the code. The reality, though, is that strong type checks do tend to be a good thing for the correctness of your code. Why? Because programs like MyPy can find, before your code is even run, if there's already known to be an error, and it tends to be good for defensive programming. So the situation essentially is that within the Python ecosystem, you can annotate your types in this way. You can use tools to use those type hints, but to date, Python itself does not enforce or expect to enforce these conventions. In larger code bases, in professional code bases, commercial code bases, probably depending on the project manager or depending on the engineering team, they may very well want themselves to be using type hints. Why? If it just decreases the probability of bugs. In fact, let me propose now that I imagine a situation where instead of expecting that meow prints meow, meow, meow some number of times, suppose that I accidentally assume that the meow function just returns meow some number of times. We saw, for instance, when focusing on unit tests, that it tends to be a good thing to have functions that return values, be it an int or a string, rather than just having some side effect, like printing things out themselves. So perhaps I'm still in that mindset, and I've just assumed mistakenly for the moment that meow returns a value like meow or meow meow or meow meow meow, a big string of some number of meows, rather than just printing it itself as it clearly does at the moment on line 3. And therefore, suppose that I accidentally did something like this. Rather than just getting the number and passing it to meow, suppose I did this. Suppose I declared a number of a new variable called meows, the type of which I think should be stir. And suppose, again, I assume accidentally that meow returns to me a string of those meows so that I myself can then print them later. This would be a little more conducive, arguably, to testing my meow function. Why? Because I could expect that it's returning meow or meow meow or meow 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 separated by new lines, returning a stir that I could then assert equals what I expect it to be in something like a unit test. I'm not going to bother writing in a unit test now, but let's just suppose that's the mindset I'm now in. And so on line 7, I'm assuming that I want to assign the return value of meow to a new variable called meows, which I've annotated with this type hint as being a stir, just so we can see another variable. This one's not an int, but a stir instead. Well, let me go ahead and run this code now. Python of meows.py, enter, typing in 3, and you'll see a curious bug, meow, 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 none. Well, why is that? Well, it turns out at the moment, my meow function only has a side effect. It just prints out meow some number of times. It doesn't explicitly return a value, as it would if there were literally the return keyword there. By default, then, when a function in Python does not explicitly return a value, its implicit return value is, in effect, none. And so what we're seeing here is this. On line 8, because I'm assigning the return value of meow, which is none, to my meows variable, line 3 is what's still printing meow, 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 and line 8 is what's now incorrectly printing none, because I accidentally thought that meow returns a value, but it doesn't, so its return value is effectively none, so I'm printing very weirdly the word none at the bottom. So how could I go about catching this kind of mistake too? Like, I might make this mistake, but maybe with less frequency if I'm in the habit of annotating my code with this new feature called type hints. What you can do here is this. Let me clear my terminal window to get rid of that artifact. And up here, let me additionally specify with some funny looking syntax that my meow function actually by design returns none. So you literally use this arrow notation in Python. When hinting what the return value of a function is, you would do this. After the parentheses, a space, a hyphen, a greater than symbol, like an arrow, and then another space, and then the type of the return value. For now, it's indeed going to return none. But now, at least, I can catch it like this. If I now run not Python, but MyPy on my code, which would be a habit I'm now getting into if using type hints, check that I'm using all of my types correctly before I even run my program, we'll see that now MyPy has found on line 7 that meow, quote unquote, does not return a value. And MyPy knows that because I have proactively annotated my meow function as having none as its return value. So now MyPy can detect that. I should now realize, oh, wait a minute, I'm being foolish here. Meow clearly does not return a value. I should not be treating it like it does on line 7. Let me go about actually fixing this now. So how do I go about fixing this? Well, let's practice what we preached in our focus on unit tests, having a function like meow not have side effects like printing itself, but let's have it return the actual string. And I can actually do this kind of cleanly. Let me clear my error message in my terminal window here. Let me get rid of the loop here. Let me say this time that, OK, fine, meow is going to return a value, an actual stir or string. So I've changed none to stir. And now I can implement this in any number of ways, maybe even using a loop. But recall that we have this syntax in Python, which will, I think, solve this problem for us. If I want to return a string of n meows, what I can actually do, recall, is this. Return, quote unquote, meow, \n times that number n. So it's kind of a clever one-liner, avoids the need for a for loop or something more involved than that, to just say multiply meow \n against itself 3 times, or n times, in this case, in general, so that I get back a big string of 0 meows, 1, 2, 3, or many more meows instead. I think now my code on line 6 is actually correct. Now I've changed meow to behave the way I was pretending to assume it always worked. So I'm storing in meows, plural, a variable that's of type stir, because now meow does have a return value of type stir itself per this type hint as well. All right, let me go ahead now and print meows. But because each of my meows comes with a trailing new line, the \n, I'm going to proactively fix what would be a minor aesthetic bug. And I'm just going to avoid outputting an extra new line at the end of those 3. So if I run python of meows.py now, type in 3, there's my meow, 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 and now no mention of none. Questions now on type hints and these annotations in MyPy and using them to defensively write code that just decreases, hopefully, the probability of your own bugs.
In the return, there is a in the return there is a double quotes that have meow/n. Why the program don't take it as a string?
Why does the program not take it as as strange?
Sí. Yeah.
So recall that early on in the class, we looked at plus as a concatenation operator that allows you to join a string on the left and the right. Multiplication is also an overloaded operator for strings, whereby if you have a string on the left and an int on the right, it will multiply the string, so to speak, by concatenating or joining that many meows all together. So this is a feature of object-oriented programming, an operator overloading, as we saw it in the past. Other questions on type hints or MyPy?
Can we not typecast this data type of this variable number?
No, you still, and let me correct the terminology, it wouldn't be called typecasting in this context because it's not like C or C++ where there's an equivalence between these types. You're technically converting on line 5 a stir to an int. You do still have to do this because MyPy, for instance, would yell at you if you were trying to assign a stir on the right to an int on the left. You must still use the int function. Int itself is still a function. It's not a type hint. But the word int is being used in another way now in these type hints. So this int is still a function call, as it always has been. This syntax on the left is another use of the keyword int, but in the form of these type hints. So you still have to do the conversion yourself.